All right, everyone, let's get started. So this is the third week of the international webinar series on advancing remote sensing application for ocean sustainability. And today, of course, we have three speakers, and today we switch moderator. Let me introduce our moderator for today. Dr. Chitraporn Phaksopa is going to be a moderator for today. She is currently an assistant professor at the Department of Marine Science, Faculty of Fishery, Kasetsat University, Thailand. Her expertise area are also involved with ocean remote sensing, ocean modeling, and other kind of physical oceanography. So I will pass the floor to Dr. Chitraporn.
Okay, can you hear me?
Yep, perfect.
Okay. Thank you, Dr. Tashanat, and good morning, everyone. Okay, for this morning, welcome everyone to international webinars on advancing remote sensing application for the sustainable development of ocean, marine, and coastal resources third week. And today, there are three interesting topics from three interesting researchers. So I think this is going to be the good time to start the first one. Okay, for the first presentation, going to be the topic about ocean color remote sensing data for the climate variability impacts on the marine ecosystem. First, let me introduce you about the presenter for today. Okay, for the first one, Dr. Myung Suk Park. Okay, now she is a principal research scientist at Korea Oceans Satellite Center at Korea Institute of Ocean Science and Technology, Korea. She researched about remote sensing, machine learning, ocean color, climate, and also tropical cyclone. And for her topic today is very interesting. So, okay, now it's time for her to start her talk. Okay, please, Dr. Myung Suk Park. Are you there? And let me remind for everyone.
Can you hear me?
Yes, I can hear you. Yes, okay. Yeah. Okay, let me remind first, you have 30 minutes, including your talk and your question for the first round. And okay, after our presenters, okay, we're gonna another round for discussion and questions, okay?
Okay. Hello, everyone. My name is Myung-suk. I am a principal research scientist from KIOST. I am also visiting scholar in NASA Goddard Space Flight Center in USA. Today, I'm going to talk about ocean color remote sensing data for climate variability impacts on the marine ecosystem. So I found out today's topic is about the advancing remote sensing application for oceans sustainability. So I searched for ocean sustainability in UN Sustainable Development Goals. So number 14, goal 14 is conserve and sustainably use the ocean, seas, and marine resources. So can we do that? So today I will firstly show about the Western North Pacific ocean warming, and secondly, ocean color remote sensing for climate impact on marine ecosystem. And lastly, our institute is working on geostationary ocean color data. So I will introduce our efforts on climate record geostationary ocean color data. So why do we concern about climate quality ocean color data? As you know, for sustainability of ocean, marine phytoplanktons are tiny plants, but widely spread throughout Earth's global oceans, about 30%. Heat is the most critical creature in climate change by absorbing carbon dioxide, CO2 in the atmosphere. Under global warming, quantify changes in phytoplankton biomass over a longer time scale is essential to examine the response of marine ecosystem and climate feedback process. So accumulating long-term ocean color data is the only way to examine the inter-annual variation in continuous way in spatial and temporal scale. And for obtain long-term time series of polar orbiting ocean color data, NASA have accumulated 20-year time series from sea whips, bodies, and bears. And one of their top priorities is to obtain the best available accuracy for individual ocean color vision record. And so they are working on sensor calibration, vicarious calibration using in situ optic data and development of atmospheric collections and level 2 biological algorithm update, and also working on multi-year trend analysis. So now we are focusing on the Western North Pacific. So I will first introduce the current state of warming. The Western North Pacific is one of the warmest ocean in the globe and gets warmer and warmer. You can see in the left panels, this is 29 degree and 30 degrees Celsius temperatures. And you can see hot temperature over tropical regions. And the right panel, you can see the increasing trend per year. So the ocean, these tropical oceans gets warmer and warmer. And also over our middle latitude, near in the East Asia, you can see warming pictures over this area. And you can also see more frequent and stronger tropical, subtropical ocean extreme warming that is called marine heat wave. So over this Western North Pacific, this is different with the mean sea surface temperature. It's like a atmospheric heat wave, sudden warming process. So it has a significant impact on marine ecosystem. So you can see the duration of marine heat wave is increasing over the Western Pacific, and frequency is increasing and intensity is increasing also. And even in the East Asia, you can see increasing marine heat wave, and these are also related basin-wide warming and also global scale circulation. This is our previous research. So now I will talk about ocean color remote sensing for climate impact on marine ecosystem. So in response to climate change, plankton show variations. Usually over the tropical area, you can see reduction of phytoplankton by global warming. But when you see this Rembert et al. 2006, you can see decreasing trend in chlorophyll trend, but also you can also see the increasing trend in early phase. This is there are global warming signals in this remote sensing time series, but you can also see inter-annual variation, such as ENSO. So it's not easy to extract global warming trend in ocean color data. And so usually in many previous studies used global model data because we can simulate everything for long times. So in this study, they simulate future change in climate modeling data, and they actually simulate the color of ocean is changing. So chlorophyll absorbed strongly in blue, such as a large amount of blue light is reflected when there is lower chlorophyll. So over the tropical regions, chlorophylls are decreasing, then you can see increased blue reflectance and greener colors for most reason in lower chlorophylls. So in the future, we can see some changes in ocean color. So this is a result from numerical model simulation. So our current work I want to introduce is so current satellite ocean color required additional decades of observation before the signal of climate change obvious over the larger region of ocean. So we thought about a better way to use the current ocean color record for detecting climate change impact. So we want to diagnose climate change impact on ocean ecosystem using NASA's heritage and current ocean color data, and suggest a new approach to analyzing the marine ecosystem change in multi-decadal ocean color data. So that is called physical mode-driven ocean color signature projection. So we can separate two climate forcing component contributions to ocean color product variations and spectrum shift. So when you usually do some kind of a multi-year trend analysis of ocean color data, this is OCCCI trend, and this is Moody's. So you just do the linear trend, you can see reduction of phytoplankton over tropical region, but not over subtropical region. You can see some dipole patterns. So this is because of it's hard to distinguish between natural and anthropogenic changes due to multiple climate physical processing, because there are global warming and also ENSO effect impacting on this ocean biological process. So we apply EOF analysis for SST. So using this methodology, we can extract major climate forcing. So for using SST variability, we extract major physical mode over Western Pacific. We found out the first mode is global warming signal, and second mode is interannual variation. And we analyze the effect of two modes on chlorophyll trends. So when this is original trend of ocean color data, and the center is the first mode, global warming effect, and second mode is interannual variation effect. So you can see the center mode, global ocean warming, you can see decreasing phytoplankton over tropical region, but also over subtropical region. And some contrast over this crucial current. So climate variability impact. So we have used the well-calibrated polar orbiting satellite, and geostationary satellite is important for regional analysis. So this is GOSI and GOSI-2. So the GOSI-2 was launched 2021. So our goal is to development of GOSI and GOSI-2 level 3 data to detect hourly to interannual variation. So I will firstly show GOSI-1 data. So you can see climatology from 3 satellites. So these are comparison of 3 satellites. You can see some consistencies in sharp gradient of chlorophyll along the cross-show current and oligotropic water over Western North Pacific. But you can also see some discrepancies like this. And this is 10 years GOSI analysis record. And here we found large GOSI versus MODIS value in later period. So you can see this blue line is GOSI. You can see some discrepancies. And this is actually artificial increasing trend. So this is related to decreasing trend in blue to green band ratio. So we need a future calibration. So from GOSI's analysis, we found out some artificial increasing trend in GOSI chlorophyll. So adjustment of GOSI calibration needed to correct the bias in trend. So these are our second satellite. This is early mission data, so we still need some update. But this is a 2-year data, and you can see the data is reasonably representing typical early spring bloom and some delayed spring bloom in East Sea. And this is GOSI and GOSI2 time series. And you can see some discontinuities in chlorophyll values between GOSI and GOSI2. So this, sorry. So GOSI2 is early mission period. So we need some update in radiative collection and vicarious calibration. So we are aiming our update in early 2023. And also GOSI2 late mission period had some sensor calibration degradation. So we need to correct this trend too. So based on our lesson from GOSI1, in GOSI2, we are developing level 3 data, but that are connected to radiative collection algorithm, because this is some process how we finally obtain chlorophyll data from satellite sensor. So what the sensors on satellite observe is some kind of digital image, and from that image we have through the radiative collections, we obtain TOA radiance and RRS, and we have these multiple process. So the first step is very important, and we need some invariant target to correct sensors performance. So we usually use sun, and GOSI2 also has a moon calibration. So we are working on sun calibration update. So GOSI1 solar calibration is has a 2 observation, so sun solar diffuser and DAMD. DAMD is a diffuser aging monitoring device. So the solar diffuser has a weekly observations, and DAMD has a monthly observation. So our work is to improve the quality of multi-year GOSI2 data. So we update the solar calibration algorithm by applying time-varying scale factors with the sensor degradation characteristics. And step 2 is to quantify how the sensor calibration biases are propagated to initial level 3 GOSI2 ocean color products. So these are typical radiative collection models. So what we wanna obtain is L radiance, TOA radiance, and the input is digital count. So usually has some polynomial equations like this is Gauss's and Moody's or RC models, and Beers also has a polynomial equation. And before that equation, it has some kind of coefficient. So currently Gauss has only Z gain. It's different depending on band. And but Moody's and Beers has a time varying factors. So they are collecting this coefficient. If a sensor has some bias, they are collecting their bias. So our plan is we also update our RC algorithm to have time varying factors. So what we are doing is a currently diagnosis initial SD gain variations and updating angle collection models. So our plan is so we are currently for long-term ocean color data, we are currently analyzing binning data, but for better stable data, we back to the early stage and correct radiative calibrations. And the other teams in our department also working on atmospheric collection and vicarious calibrations, and many other research groups are working on bi-optical algorithm for each product. So for these accumulated efforts, we want to have a better climate data record, well-calibrated data. So this is my summary. I firstly showed the Western North Pacific gets warmer and warmer. So like 0.4 degree per 10 years, 7 days per 10 years marine heat wave duration extensions. Response of climate impacts on satellite ocean color data record has been uncertain. So when we analyze NASA's Heritage Polar Orbiting Time Series, when we perform some kind of trend analysis, many reasons remain uncertain, because that is because of compensating effect of global warming and natural interannual perturbation. So we saw our analysis use physical primary mode impact investigation of ocean color data. That method revealed some sea surface warming effect on ocean ecosystem. So firstly, that shows positive SST trend. First mode induced decreasing phytoplankton over the tropical ocean. That is a well-known features. And but the second point, the global ocean warming mode also induced decreasing phytoplankton over subtropical ocean was. This signal was not shown in previous trend analysis, but when we extract each major climate mode, then we can, when we examine the impact to ocean color, we could find that subtropical region also have a decreasing phytoplankton trend. And also this contrast was not well seen in previous trend analysis, but we can see contrasting response of positive and negative trend occurred around the cross-shore current. This is very apparent. And for regional change of ocean biochemical process, it is critical to maintain long-term data stability of GOSI and GOSI-2. And GOSI-2 is early mission period. So we found, we are still working on update. We found discontinuities, but we are working on sensor calibration and vicarious calibration. So we are on the update will be planned in next year, early next year. So, so this topic in our webinar is ocean, sustainable ocean. So I thought about our rules for sustainable oceans. I am a remote sensing data provider, but also I'm working on climate. I can be also climate scientist. For remote sensing scientist, I should do my best to maintain long-term climate data stability. So then we can provide data to many scientists. Then they can diagnose and models the current and future ocean change more efficiently. And finally, I think we should persuade some decision maker. So we need to accumulate many evidence for changing oceans. Then decision makers make a better decisions, and they can develop policies for sustainable oceans. That's my concluding remarks. So thank you. If you have any questions and suggestions, you can also send me email. Thank you.
Okay, thank you. Okay, thank you, Dr. Myung-Sung Park. It's it's very nice presentation, and it's very interesting topics about new. Okay, I can say like a new satellite. And okay, it's time for question. Any questions for Dr. Myung-Sung Park? Okay, please raise your hand. Okay, Wensi, please.
Hey, thank you very much, for your very, inspiring work that has been done by KOSC, Korea Ocean Satellite Center. We have heard of GOSI for more than a decade.
Yeah.
Right? You mentioned about GOSI 3. That's still under development or already launched.
GOSI
3.
GOSI 3. We are planning GOSI 3. So GOSI 2 was launched 2 years ago. Right. And so we want to launch GOSI 3 on 2030, but depends on budget. So we are working on planning project.
Okay, thank you. My question is, many studies are still, many remote sensing, application you presented still, at a study level, I feel. I just wonder there's a kind of operational, use of GOSI in Korea, for instance, for meteorological agency or for fishery agency or for hydrological agency, whether they use GOSI data or products into their operational basis,
So today's topic is ocean sustainability. That's why I chose this. I show this result, and our department, Korean Ocean Satellite Center, we are also developing sargassum detections and red tide detections and sea fog detections using GOSI data, and we are providing those algorithms to operational centers, and they are using it. Yeah, so these are just scientific portions. Study, right. And and we also have many. We are working on half and half, science and operation, but we are working on operational technical development.
Okay, thank you very much.
Thank you.
Right.
Okay, I think we have time. Okay, so one more question, please. Okay, from Jamstack. Okay, please.
Thank you very much. My name is Ken Ando from Jamstack.
Cannot hear you clearly, Can you get close to the microphone?
Oh,
Yeah,
sorry,
please.
my microphone today is very far, sorry.
Uh-huh.
You show the, increasing, so you show the SST is increasing, then
Uh-huh. Uh-huh.
the chlorophyll A is decreasing. But
Uh-huh.
you also show the increasing trend of chlorophyll A.
Over in the mid latitude.
Yeah, in the mid.
Yeah. Mm.
And increasing, so I understand probably due to the increase of SST may cause the stronger stratification.
Uh-huh.
Then-
Yeah.
Then chlorophyll A will decrease. However, why do you have any scientific insight about the relation of increasing of chlorophyll A due to the increasing of SST?
I see.
What's the reason?
Yeah.
Yeah. So there are actually this research. So the structure of oceans are different in tropics and middle latitude. So this Donny et al. Mentioned about it. So high latitude reasons, climate warming, freshening, and reduced mixing, increase in phytoplankton in surface waters. So that's their explanation. So actually, when in our result, you can see this. So when the left one is a trend analysis and the center one is the only global warming effect. And you can see this contrast along the current. So actually that's, I am working on these discussions, but I have my hypothesis. So these are shallow water areas. So when as I know, there is the current is forward moving, and so the crucial current is forward moving and more intensified. So that may cause more nutrient from shallow water. It's a similar thing happened in Gulf Stream, but it's just my my hypothesis. We need more investigation for clarification.
Maybe your hypothesis is maybe due to the turbulence. By the
Yeah.
Okay. It is common that it is common recognition that the cross shear will be stronger.
Oh yeah.
By the due to the global warming. Yeah, I understand.
Yeah.
Thank you very much.
Thank you.
Okay, thank you everyone for questions, and thank you again, Dr. Myung Sung Park, for your good presentation. And okay, please still be here, and we're gonna have another round for discussion and questions. Okay, thank you, and we are looking forward to both project 2 and 3 in the future. Okay, now I will move to the next presentation. Okay, let me is that okay? So first, let me introduce the second presenter. Okay, Professor Huo Gao Zhang. Now he working at State Key Laboratory of Satellite Ocean Environment Dynamics at Second Institute of Oceanography, Ministry of Natural Resources, China. And his research is about the application of remote sensing to monitor the coastal and offshore environment. From the person until now, he has a lot of projects and a lot of publication about remote sensing and the causal changes. Okay, and today he will talk the topic of remote sensing, monitoring, and application of coastal zone, ecological protection and restorations. Okay, now you have 30 minutes, including your talk and your questions. Okay, please. Professor Zhang.
Okay, thank you. Good morning, everyone. My name is Huo Zhang. I'm from State Key Laboratory of Satellite Ocean Environment Dynamics, Second Institute of Oceanography, Ministry of Natural Resources, China. Today, I'm very glad to share my work about remote sensing, monitoring, and application of coastal zone ecological protection and restoration. And this is the outline of my talk. It's include background and 3 cases in China and Pacific Island countries. First is the background. As we know, United Nations 2030 agenda has set out 17 sustainable development goals, which are most of those are closely related to the ecological health and sustainable resource use, especially SDG 14 focuses on the life below water, which includes a number of activities for the coastal ecosystems. Recently, United Nations also declared a decade of ocean. Its vision is the science we need for the ocean we want. And only in 2021, there are 31 programs and 93 projects have been approved. So in China attaches great importance to the ecosystem's health, especially in the coastal zone. The Blue Bay remediation campaign started 10 years ago is the beginning of the coastal zone ecological restoration project. Since then, more than 10 new projects are launched every year. Up to now, a total of 143 national coastal ecological restoration projects have launched. And each project received more than 300 million yuan from central government and more from local governments. So now I will present the case 1 in the Hainan province, China. It's a case of remote sensing supporting of the Xincheng Lagoon Blue Bay project. The case site is the Xincheng Lagoon in the southeast of the Hainan Island, China, facing South China Sea. And the Xincheng Lagoon is a middle-size and semi-enclosed coastal sandbar lagoon system. The tide channel is about 3 to 4 kilometers. Now the Xincheng Lagoon has many ecological risks, including mangrove losing, seagrass degradation, beach erosion, and over aquaculture. My talk is focused on the beach erosion and in the red flame. This is a remote sensing image of the area, and we can see it's a red line is the tidal channel, and this is the west sand speed, and this is the east sand speed. So a total of 153 sensors of high quality and cloud-free remote sensing image from 1962 and between 1962 and 2018 were collected, and all the images imaging depths and tidal level for the images are listed below picture. And this is the 4 typical images in different year. It reveals a different pattern of the shore sandbars in different years. For example, in 1968, there are a middle shore sandbar. This is the middle shore sandbar is appeared, and in 2003 and 2009, the east sand speed it become longer and extend from east to west significantly. In 2016, the east sand speed become very long, more than 1,200 meters. And how to get the shore sandbar information? As here I present the methods. Because the shore line is located underwater and its location needs to be determined by water depths and spectral characteristics. For this, we first to retrieve the water depths based on the remote sensing image. See this picture, the black curve is the water depth, and the black dashed line represents a depth of 1 meter, and it's very matched with the spectral band green and band red. We determined the boundary of the shore line at L1, L2, 3, and 4. So we can get the shore sandbar and the shore sandbar. And this is a tidal channel. Here is the open sea. So all of this image is the shore sandbar pattern in different years from 1962 to 2018. We can find that it's changed regularly. This is an enlarged image. We can see in the pattern in 1968 and 1986. They have similar pattern, but in the middle years in 1978 is very different for them. Here we count the length and the area of the shore sandbar. In this picture, we can see the 3 parts of east sand speed, middle shore sandbar, and the west sand speed. We can see the east sand speed length is become longer and longer, and then suddenly become shorter, then become longer and longer, and also has regularly changed. So we can get that the shore sandbar goes periodic evolution. Now, based on the length of the east sand speed, we can get that the length of east sand speed is become longer, about 60 to 70 meters per year, and 4 times sudden shortly also has happened. So we based on the length of east sand speed, we can 4 sandbar bleaching were recognized, that denoted in the T1 in 1967, and 2 is middle 1980s. and 3 in 1997, and 4 is 2017. So the entire period could be divided into 5 circles. 3, 1, 2, 3, 3, 3, 2, 3, 4, and 5. And here show the information of the main current curve of the tidal channel, and the center point of the show sandbar patch, and the cycles 1, 2, 3, 4. In this picture, we can find that the tidal channel and the show sandbar both moved from east to west, Then suddenly back east, then local. These are cycle process. So in order to understand the periodic evolution process, we develop a conceptual model of the periodical evolution. This model consists of 4 continuous and cyclical states, named S1 to S4. In the S1 is double inlet state. They have a complete separation of eastern sand spit into 2 parts, because they have 2 inlet in this area, 2 inlet, and then the state 2 is merging and adjustment state. At this state, the middle show sandbar were merged with the west sand spit, and when this process is complete, it's into the state 3, named basic state, because it's the most stable in the evolution cycle, and where its time also is the longest duration within the cycle. So when this east sand speech become longer and longer, they have enter the 4th state, named bleaching state. They will have a bleaching and break the east sand spit again. So this cycle and the cycle is found in above remote sensing information. So we can count the time is about 15 to 20 years a circle, and each of stage have also its different long, and most of the time is the state 3. So as conclusion, we found that the pattern and the models explaining the process of beaching erosion and restoration provide a scientific basis for the natural-based solution for the coastal remediation in the Blue Bay project of Xincheng Lagoon. Because this 3 picture is the same place. I take the different year. We can see when the east sand spit is very longer, so they have the heavy erosion. But when the sandbar bleaching is completed, it's the erosion will restoration again. So next, we present the second case in Zhejiang Province, China. It's about affecting monitoring and the evolution of coastal zone ecological restoration projects. Since 2016, Zhejiang Province has carried out 4 national Blue Bay remediation action in Ningbo, Zhoushan, and Taizhou City. And since 2018, Zhejiang Province has carried out a 3-year action plan for coastal restoration and completed the restoration of about 343 kilometer coastline. And this is the place of all the projects. This is the workflow of the remote sensing monitoring and evaluation. First, we will get some remote sensing images before and after the projects. Then we will collect the field survey by UAV and RTK and so on. Finally, we can implementation the remote sensing image information include the geomorphic integrity, land ecologization, and beach ecological healthy, and so on. So here is some example. First project work is Jiaxing City. Here, use remote sensing images showed that the Spartina altifolia was almost removed from the intertidal zone, and the area of surplus mariculture increased to 17 hectares, account for about 76% of the intertidal plant area. And here is a UAV photos taken in June in June and 2000 this year. So we can see the effect of the coastal tidal zone restoration is very good. So another project is in Wenzhou City. At the beach restoration place, we used 6 remote sensing images to monitoring. So after the beach restoration projection in 2016, the length of the beach doubled and the area increased by 5 times, and the beach area was stable. From this table, we can see this information, and so we think that the restoration is successfully. And at the mangrove restoration from 2016 to 2019, there are about 36 hectares of Spartina atomifera was removed in this area. And then there are 25 hectares of mangrove in 2021, and 40 hectares of mangrove last month were observed in remote sensing image and UAV, respectively. So we think the mangrove has been restored successfully in this area. The last case is some work in the Pacific Island country. I want to introduce remote sensing monitoring and coastal ecological environment in Pacific Island countries. It's a view of our work, and there are a total of 20 ecological elements and disaster monitoring in the coastal zone, benthic habitats and marine ecosystems. It's one example is coastal erosion, and these three images show the coastal dynamic change from the remote sensing images in the Papua New Guinea, and we can guess that the coastline varied up to about 1 kilometer. It's very obvious. There's another place in the Solomon Islands. We can see this island is disappearing, become smaller and smaller. So we completed all of the Pacific Island countries coastal erosion monitoring from 2000 and 2020. This is a statistic of the number and the area, and this is area and the coastal zone in each country. In total, there are 3,023 coastal erosion has detected, and the total area is about 245 square kilometers. And next example is coral reef bleaching monitoring. We use the satellite remote sensing images. We inverted the bottom reflectance of Kuria Island and Kiribati. And this is the shows the bottom reflectance in the coral reef area. And when we use the time series bottom reflectance to identify the spatial and the temporal pattern of coral reef bleaching and recovery. This is the results. We can in the red area is bleaching and the green area is recovery. We can see it's changed. Is periodic evolution. So we select 5 typical area, A, B, C, D, E, of each type of the coral reefs. We compared with the bottom reflectance with the NOAA coral bleaching temperature products. We can see that the trends, they are consistent with each other well. So this just suggests that our method and products is reasonable in the coral reef bleaching in Pacific Island country area. So that's all. Thanks. It's all of my talk. Thank you.
Okay, thank you so much. Okay, Professor Zhang. Okay, it's very nice presentation, and I think everyone knows about the problem about coastal changes is one of the big problem. Yeah, like every country that have the coastline. And okay, now we still have time for questions. Maybe just one or two questions. Okay, anyone has an okay? We have one question from Dr. Kunchon Pusawanga, please. Any questions? Okay, so okay, and actually I have one question about this. Okay, when you're talking about the conceptual model about periodic evolution process, and actually for this conceptual model, how many years do you need to get this idea or to get this process?
In the first case, we
Yes,
used about first case. We used about 56 years remote sensing images.
Okay. 56 years. Okay. Yeah, this is really quite long. Yeah, to get to know about this process.
Because its cycle period is about 15 and to 20 years. So we needed 3 or 4 double long. Yeah.
Okay, I see. So that is today I get a lot of ideas how to apply your your research to Thailand, because it's in Thailand. As I think you might visit Thailand sometimes. Yes, we have a lot of problem about the causal erosion too, and I think remote sensing gonna be the useful tool to help us to study this problem and find a better way to solve this problem in the future. Okay,
Yes.
now, yes, okay, thank you so much. And okay, now it's time for the next presentation. Okay, thank you so much, Professor Zhang.
Thank you.
Thank you. Okay, let's move to the last talk for today. Okay, he's there. Dr. Assam, are you there? Dr. Assam? Okay. Okay, he's not here yet. Okay, let me contact him first. Dr. Assam, are you there?
I saw him some time ago. Maybe he have problem with internet, I think.
Yes. Okay, while we're waiting him get back to our talk. Okay, so I think it's time for maybe we can get some discussion about about the first one and the second presentation. Okay, so if you have any questions or any suggestion or any comments about remote sensing for causal changes or the climate change vulnerability, okay, we can discuss now during while we're waiting him back to our talk. I'm trying to call him.
So I back up. Sorry.
ฮัลโหล
ค่ะ
ไม่ตักไม่งั้นน่ะเดี๋ยวตอนเนี้ยพยายามกระตุ้นdiscussion ก่อน
ค่ะ
ก็คำถาม discussion ไปก่อนเดี๋ยวถ้า discussion จบถ้าเขายังเข้าไม่ได้เราก็คงต้องยกเลิกเขามั้ง
ได้โอเคค่ะเพราะเมื่อกี้เพิ่งคุยกับกิจช่วยกันตามฝั่งนู้นอยู่อะค่ะ
ครับ
ได้ค่ะโอเคค่ะขอบคุณค่ะ
ครับตักเริ่มชวน discussion ได้เลย
Okay, now while we waiting for Dr. SM for the last presentation, now we can discuss about the topic today. So for today we have two different works. The first one gonna be the application of remote sensing on climate variability. For example, like a chlorophyll concentration or CDOM by using GOSI 2 and GOSI 3. And the other one from Professor Zhang, he talking about application of remote sensing and the causal changes. And I think for both topic is very interesting, and many countries try to apply remote sensing for this technique. Okay, sorry. Okay, so for me, I think for both topic is kind of touch our eyes, and especially using the remote sensing and the causal changes, because it's especially in Thailand, we have both sides, Gulf of Thailand and Andaman Sea, and we also try to apply this technique to our country too. So I think I saw somebody who studied about remote sensing and causal changes in Thailand. Do you have any idea or any research to share about us? Please feel free to share your experience about this remote sensing and the causal changes in Thailand or other country. Even the other one, we're using ocean color sensor to study about chlorophyll A and CDOMs in Gulf of Thailand or the other area too. So please feel free to join us and feel free to give some comments or suggestions.
Actually, I have question to Dr. Mongsu. Can you join us?
Yeah, she's here.
Since you currently at NASA Goddard, right? So can you tell us like a bit more about milestone, present or current milestone from Goddard side and also Gaudi side in terms of ocean ecology related to satellite remote sensing? You're still muted.
You're still muted. Okay, please.
You mentioned about milestone of NASA.
Yeah, NASA got this.
Yeah.
Right.
I'm visiting here, so I stay here but I know that actually in our current GOSI, using GOSI and GOSI 2 data, we cannot analyze climate change effect yet because we need to calibrate our data. But they have the NASA has more than 25 accumulated data from CWIPs, bodies, and beers, and they tried to best to calibrate each sensor, and they analyzed the multi-satellite trend, and so in regarding the topic, my presentations, they accumulated 25 years time series that that everyone can apply for climate detections. Yeah, that's one milestone, and there are many milestones.
And during your talk, you mentioned about top of atmosphere, atmospheric correction rate. Do you think global energy budget has already changed in some way?
Global energy, that's actually not my focus. Yeah. In my focus, TOA radiance, we for estimating TOA radiance, we need some conversion process from sensor detected image to TOA radiance, and sensor has a different performance in time, so we use solar diffuser to calibrate our sensor. That's my focus. So I think I am not the proper person to answer the questions. TOA radiance is changing. I don't know. Yeah.
Okay, I don't know too.
Yeah.
Thank you.
Yeah.
Okay, thank you. And from your presentation, I saw you mentioned about you use level 3 data, right? Level 3 image.
Me?
Yes.
What kind of laboratory image?
Pardon, sorry.
What kind of laboratory image did you?
I think you talk about some chlorophyll A, something like that, but I'm not sure. Maybe I'm wrong. But I saw you some some slides you talking about the level 3 image of Gorgie 2 and Gorgie 3.
Yeah. That's from satellite.
Yes.
But we also working on evaluation of chlorophyll using laboratory data. We had our research vessels. KIOST has a Isabu and Onuri research ship. So we using we are making observations, optical observations and biological product observations, and we are working on evaluation of the satellite product. But what I used was a satellite derived chlorophyll.
Okay, thank you.
Yeah.
And actually, I have questions for Professor Zhang. Yes, I think you mentioned about mostly your case study about the coastal area. Do you have any plan or any research about using satellite data and coral reef ecosystem? Professor Zhang, are you there?
Yeah, I'm here. Yeah.
Right.
But I just now may couldn't hear clear your question. Yeah.
Okay. Yeah. Okay. So actually, I'm interested about the coral reef ecosystem. Do you have any plan or any idea about using remote sensing and the coral reef ecosystem observation yet? Thank you.
Okay. I wanted to say the coral reef ecosystem. The remote sensing can carry out the monitoring the coral reef ecosystem, especially in the wide spread wide area of the open ocean. So we couldn't carry the survey survey, field survey. Field survey is different and cost and the cost also is very huge. So we want to develop some method to monitoring the coral reef using the satellite remote sensing without ground truth data supporting. So our in my talk, the third case, the third case and the bottom reflectance is derived from the remote sensing image without any other true step supporting. So we think use this method can use to all over the world, everywhere. The coral reefs in monitoring the coral reef bleaching. It's important. It's important value of this method because we know the multi-spectral band remote sensing data is very enough from the satellite. So we can use this data to complete coral reef ecosystem monitoring. Yeah, this is my understanding of your question. Yeah.
Okay, all right. Thank you. And okay, Wency. Okay. Wency, please.
Oh, thank you very much, for giving me the opportunity. Indeed, I would like to, to have some interaction with our two speakers today because, as Myung-Suk highlighted, the webinar focused on application of remote sensing to ocean sustainability. I think today, the two talks indeed reflect the ocean sustainability at different time scales. For the first one, I think Myung-Suk presented about using the remote sensing to understand the impact of climate, in ocean ecosystem. In this specific case, on the, the chlorophyll in open sea. I think this is the case, provide a window how remote sensing group, using remote technology to look at the change in the ocean ecosystem, what happened to the ocean ecosystem. So this is something, if we want to know, okay, how to sustain the Earth, including the ocean sustainability, we can go in that direction. For Hua Guo's presentation, I think it's also very practical because he gave a full case, of applying remote sensing to, coastline change, to the even coral reef bleaching, right? And also to those kind of habitat mapping. I think two talk are very inspiring. So my question is, to the first speaker, Myung-Suk, based on as you mentioned, based on 25 years time series data, okay, even there are some kind of uncertainty, even we know, okay, the global warming will lead to the strong ocean stratification. And finally, will result in, that kind of reduction of nutrients as chlorophyll, as in this case, in the open ocean. So what a policymaker can do, right? This is something, because in your last slides, finally, we need, come from science knowledge to decision to action. So yeah, even we understand, okay, there's a reduction in the open ocean. What a policymaker can do?
That's I am not the right person to. I'm not a
No,
decision
just
maker.
we just explore, you know.
Yeah, but before it, decision makers are usually government employers, and they can spend some government money to protect the environment. But before that, I think we need more study, more science to convince them to change their policy or change their decisions. So I think currently, yeah, we don't have enough evidence. This is so serious. So I think, as I suggested in last page, I felt that many remote sensing in ocean color study focus on the short-term variability study, but I think we need more study to detect long-term variability. But in that, it's very important to separate artificial or artificial trend and real trend. But anyway, it's important to diagnose current stage in various regions. We can do some regional study too, or even in the near Thailand. So, and our regional study should be performed by the regional peoples. So they are regional oceanographers are well known about the regional ocean currents and detailed information. So I don't know about how decision maker have a better policy, but I think before that we need to put more efforts to accumulate the evidence for changing.
Right. Yeah, thank you, Ming-Su. The reason for me to ask the question is, there in this region, there are many countries still developing country. That means the government always put limited resources in ocean scientific research because understandable, they also have other, pressing challenges for them to address as a policymaker. So this is because IOC is a kind of intergovernmental body. Now we work together with both sides, policymaker and our scientific community. We also have this challenge, how to convince the country investing more money in ocean scientific research, observation, including remote sensing work. So we need to find we have been thinking about what's the right strategy, right? Either, there are a lot of scientific knowledge. We know global warming. Okay, for policymaker easy. Okay, just reduce the the greenhouse emission and also try to increase the carbon, stock capacity, right? This is simple. But for our ocean, yes, we understand, okay, ocean warming, ocean stratification increase. And somehow in open ocean, even, some, the primary productive decrease. But what else we can do, to convince them to put more money in scientific research? Right, you understand what? That's why when we do the research, on the other hand, we also need to consider what policymakers, how they think about it, to give some kind of a, very, how to say, convincing evidence, right? And encourage them to put more investment. This is just some kind of a, not very much related to the scientific study, but indeed very critical, I think, strategic question for our people working in the region. Right. Thank you very much, Ming-Su. 25 years, your study is based on 25 years data, right?
Yeah.
Time series. Okay.
Dr. Samkiat, please.
Yes, I have the question to Ming-Su because I relate to when she question asked you, because from your study, your study in open water, right? I think maybe it's good, to better understand those have the impact to the social, if we can focus study on on the fishing ground, you know, the same as your study on the fishing ground, how is impact on the fishing ground? Because I understand that more of the fishing ground, there are some other physical processes, you know, to make that kind of fishery is enhance productivities. That maybe we don't know that this one also impact on the fishing ground. The fishing ground may be not large, right? The open ocean. I think that if you can focus on those kind of fishing ground, I think maybe we can more understand, you know, what the impact we happen to the fishery. Maybe those information, so it's good for those kind of policy maker to think about, you know, about mitigation or adaptation for the fishery. Yeah, that is one of my suggestion.
So you talk about fishing catch.
No, yeah,
fishing ground.
fishing
Yeah.
ground.
Fishing
You know,
ground.
yeah,
Right.
yeah. Yeah,
Right.
if you are because now you are present about the open ocean, but we don't know that actually, you know, it impact on the fishery or not, because normally the fishery, they have particular fishing ground, you know, and then if you can focus on the fishing ground, maybe we can more understand, you know, what is the problem, is have the problem there or not, because normally I know that the fishery there, what you call the success of the fishery in the fishing ground, because there are some kind of physical processes, ocean processes, contributes that kind of productivity into the area. But we don't know that this kind, you know, the climate change also impact to those area or not. Yeah, this is from my suggestion.
Thank you for your suggestion. I agree with you. And fishery is some topic that government decision makers are interested in. So that's a good way to go. Thank you.
Right. Okay. Can I have one more question to the second speakers? Yeah.
Professor John, are you there?
I think he was there. Hua Guo,
Yeah.
are you there? My question to you, I think Hua Guo's presentation very practical, you know. I think in many cases, you know, the remote sensing, you know, really demonstrated our efficient tool for monitoring the coastline change and also coastal developments. It's very, you know, inspiring that today, I know that even today, you know, his study can use the remote sensing to understand the evolution of shore sandbar, right, over the last 50 years. I think as demonstrated by the Hainan case. But yes, as you know, the Dr. Jirapong mentioned that maybe there's something, you know, I think in terms of Thailand with your very severe coastal erosion case, with most of coastal erosion was addressed just by physical right way. I think in order to address the issue in a long time, I think such kind of you know, the study on ocean dynamics with the help of ocean offer, you know, remote sensing may be helpful. You know, I think also in our country, in Vietnam, our last coastal area now is under very rapid development, right? You know, reclamation, aquaculture, and habitat loss. I think this is also way. The third question is about the coral reef. I think I follow up to the question with the question raised from our moderators. I saw you did a lot of study in the South Pacific islands. You also mentioned that, you know, remote sensing is a kind of very important complementary tool, you know, for remote areas, right? For the work in the remote areas. What the work you do in the South Pacific, either shallow water or deep water, and also, you know, I think this is the issue as well, because South Pacific, I think, are relatively, you know, the water environment relatively clean with the right, with low stability, maybe, you know, relatively easier to use remote sensing to map the remote coral reef. But how about the coastal issues, you know, in the Southeast Asia or East Asia? Yeah, frankly, because you know, the coral reef use remote sensing to map coral reef is always a challenge, right? So what's your experience or even lessons you have before when you do that coral reef related remote sensing work? 华国，明白我的意思吗？就是 remote sensing 这个你们那边碰到一些问题，大家都很明白，你可以很 feel free to share your lessons 啊。
Means that you mean the main limitation for the remote sensing for the coral reefs in coral reef monitoring?
Yes. Could be limitation or lessons, something.
Okay. I think two aspects to explain this question. The first is in the depths, water depths also in the main factor to affect the monitoring capability for the coral reefs. In our research, it's about 30 meters. 30 meters means the limitation. So we in the Pacific Island country, maybe only the shallow than 30 meters area. But in the other mainland coastal, maybe it's very difficult, even because we have some case in the China Island. Maybe the water depth only shallow about 5 meters.
5 to 10 meters.
Meters. Yeah.
Right.
So even in this the extensively shallow water, that the result also the result still is not good. Still
not good enough, right?
Yeah. In the so I think in the I think this remote sensing for the remote area island for the coral reef is very valuable for worldwide. Worldwide is worldwide. Because I want to carry out for the whole Pacific Island more than several thousand islands. So that work is progress now. Yes.
Okay, that's good. Because as you said, simply because the water is clean, right? It's much cleaner than others without much disturbance. So you can find a better results, right? Right. You see, this is another question in the chat box.
Yes, we have one more questions. Okay, so the question is, how significantly is acoustic remote sensing being used to study the coastal and offshore water in East Asia?
East Asia. East Asia. Yeah, I can. You means also the coral reef East Asia?
I think he asked about the acoustic remote sensing.
Yeah,
acoustic.
Acoustic. What's it? I don't understand the acoustic. What's it?
Yeah, can you explain? I think that Mariam Han. Can you just speak out your question?
Mariam Khan, are you there?
Yeah, maybe you can explain a little bit more about your question, right? That's a, you know, both of us are not native English speakers, so feel free to,
Okay. Okay. Now I'm seeing Dr. Assam again. Okay, Dr. Assam, are you there? Dr. Assam. I think maybe his connection is lost again. Okay.
Right.
And Mariam Khan, are you there? Can you explain more about your questions, please? She says she cannot turn on the mic on. Yeah, okay.
Yeah, if based on my understanding about the acoustic remote sensing, maybe she meant, yeah, maybe if I come with you, you can say correct or not. If I understand acoustic remote sensing, acoustic is some kind you use those kind of the noise wave, right? And then normally they use in the fishery, they have to use in the nowadays a sensor have to use in the submerged water to detect, you know, what was it, for example, the fish community or fish school in the water column or benthic community, those kind of things. If I understand correctly, is it correct, right? Not correct? Please say yes or no. Yes.
Hua, you understand the questions? Hua, you understand? Do you understand the questions?
Am I audible now?
Oh, they're not of noise.
Hello.
Yes, yes. Who is talking? Who is speaking?
This is Mariam. This is Mariam.
Right, right.
Actually, I couldn't turn my mic on earlier.
Okay. Hi.
Okay, so my question was basically based upon the use of acoustic remote sensing, mainly the use of ADCPs and CTDs and the different physical oceanography instrumentations to study the coastal and offshore waters. Like how deeply is it being used, or how deeply is it being integrated with the satellite remote sensing?
Yeah. Yeah. Okay. Hua, can you understand? I think maybe this question to you or to some other remote sensing colleagues.
Yes, I see the question on the switchboard.
Right.
Yes. My research area is about the
ocean color.
Main ocean color, optical remote sensing and microwave remote sensing, not the
acoustic.
Yes, not the acoustic remote sensing. Yes.
Yeah.
Thank you.
Yeah. Okay. I think Minsu also working on mainly on ocean color and optical, not acoustic.
Yes.
Maybe the Argo floats and probably the data from the Argo floats can be used for the validation of the like ocean color remote sensing.
Oh yeah, right. Yeah, I think Mary, yeah, I think remote sensing colleagues need to take any, any possible in situ data, including Argo flows, to validate, right, their remote sensing products. Hua, my understanding correct, right?
Yeah, yes.
Right, and even for Argo data, SST certainly is a very important, to validate SST products, remote sensing, definitely, but not only, right?
Yeah.
The more the better. Right. Acoustic, yes, we haven't got any speakers over last 3 years, over last 3 webinars who specialize in acoustic remote sensing, but this is something. Okay, anything else? I think maybe we cannot wait too long for Isam from Bangladesh, right? Bangladesh.
Yes.
over here?
Yes. Yes. We cannot.
Hello. Hello.
Yes,
Ah.
Azam.
Yeah.
Yes.
So just wait 1 or 2 minutes. Just I'm connecting with the slide.
Actually, now we have just 9 minutes. for
Only 9
today.
minutes?
Yes,
Yes,
because
yes,
it's
yes.
yes, our session we're gonna close about 11 a.m.
Yeah.
So I think just 9 minutes. I think you cannot finish your talk or anything. What do you think about this, Vinci? Can we extend his talk?
Azam, apologize because we also need to be responsible for all our audience because we plan to, to have the schedule or to complete in 9 minutes. If you don't mind, how about we move your lecture to the next webinar? I noticed there's still webinar, only 2 speakers, right?
Okay.
Tana chat.
Yeah, yes,
Right,
yes,
right.
yes.
How
for
about
next
move
That's what I'm
Azam
gonna
to that
talk.
one? Okay.
That's
Next
what I'm gonna
webinar?
tell.
Okay.
Sorry, I was in the on the way to just in a transfer from one city to other city, so I become late for the traffic. So as the time doesn't permit, then I can take the other one. It's up to you.
Right. Okay.
Yeah.
Thank you, Azam.
Yeah.
Okay, thank you. Yes, okay. We're gonna move your talk to next week because it's next week we have just two to talk, and it's okay. Thank you so much, Dr. Azam.
Yeah, thank you so much. Thank you.
We miss you too much.
Yes.
Okay. Yeah, please.
Bye-bye.
Okay, thank you, and thank you everyone for joining us for today. And before we closing today, we need a group photo. Okay, everyone, please turn on your video, and we need group photo. Oh, I forgot myself. Okay, sorry. Okay. Okay. 1, 2, 3. Okay, one more, please. 1, 2, 3. All right. Okay. Thank you so much, everyone, today. So we have a great time to listen and also discuss and some question about very interesting topic or 2 different talk. And we hope everyone will join us again next week. And for next week, we have 3 presented about water qualities, about seasonal and interannual time scales from Thailand and also from Dr. Azam. Okay. And thank you everyone for joining us today, and see you again next week. Okay. Thank you everyone.
Okay. Thank you, Minsu, and also Hua for your very good presentation.
Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye.